Hey, all. Today we're going to continue talking about two quantitative variables and comparing them using scatter plots. And today we are going to get into linear regression, where we can put an equation to the trend of our data and also use that data to make some predictions. So here we have some data on Toyota Corollas within 250 miles of this town in California. And we have documented the age of the Toyota Corolla, so how long it's been around, and then its price that's advertised on CarMax. And so we're going to take this data and we're going to put it into our calculator. Just be careful when you're doing that. I've had to split the columns here, so I have age and price, and then age and price again. So in our calculator, we can stat, edit, and we can put all our ages in order and then all the prices in order. So each age should match up with its corresponding price. So go ahead and pause right now and get that data into the calculator, and then we can talk about doing some linear regression. So you should have that in your calculator. And as you can see, we are going to use that data to create a scatter plot, which we did last lesson, but we'll do again. And so just to remind you, we can do second y equals, go to our plot, make sure it's on. We are going to choose the first option. I was using this calculator earlier, so I got to change my lists. My X list should be my ages, L1. My Y list will be my prices, L2. And then I can zoom 9, and I can get my scatter plot. And so we talked in the last lesson about the form, the strength, and the direction. Here we have a linear relationship. Looks like we are in a straight line path. Looks like a pretty strong relationship. The data points are packed in pretty tightly. And we have a negative relationship, meaning as our age increases, our price decreases. And so we are going to now calculate a line of regression. And I'll show you how to get to the steps. We're looking for this output when we're finished. We will start by doing stat and then calculate. And when you go to the calculate, you'll see that there are two linear regression options. We're going to choose option 8, A plus BX. That is the appropriate option in statistics. So I am going to stat calc. I'm going to go down to option 8. You can just press the number 8 if you want to. My X list again is L1. My Y list is L2. Yours is probably okay, but I was using my calculator for a different problem earlier. And then in this store right here, I want you to press vars. And if you look down here, you can actually follow my clicks in case you get behind. I want you to arrow to the right to Y vars and hit enter on function. And then you're going to hit enter on number 1. And that's going to give us an equation. It's going to graph us an equation, which we'll look at in a minute. And so we can hit calculate, and you should get the screen I got before. If you're not getting this screen, make sure you go to mode and you arrow down to stat diagnostics and make sure they are turned on. And then you'll have to go back and run that regression again. And then again, we'll have to make sure we store that equation. So you should have a screen that looks like this. We've talked about correlation already. It should be a pretty strong, so close to 1, negative, so actually close to -1 relationship, which it is, -0.944 and some change. So it's a really strong negative relationship. Doesn't mean it's a bad relationship. It just means it's going down to the right. We get this R² value, which we'll talk about in the next lesson. And then A and B are going to help us write an equation that models our trend in our data. So you can see at the top here, we have y equals a plus bx. That means that a is our y-intercept and b is our slope, if we're thinking back to algebra. We want to write our equation or our model. I'll use those interchangeably. This is a linear model. We're trying to model the relationship here between the age of our Corollas and how much they're listed for. We're going to write that with our actual variables in the equation. So our y, or our dependent variable, our response variable, all those different names, is the price. And then I will start with my y-intercept. And I'm going to go ahead and round to 2 decimal places. I'll put my slope in there. And then my x variable, my independent variable, my explanatory variable was the age of the car. So I'll put in parentheses age. And one thing I'm going to add to this equation is over price. I'm going to put this little, looks like the roof of a house. We call it a hat. And what that represents to us in statistics is that whatever value we get there for price is a prediction. So we can use this equation to model the relationship, and we can make some predictions, which we will, but it won't give us an exact value that a car is going to sell for, because we don't really know. The prices vary. You can see even in the data set, we have some cars that are the same age, but are different prices. And there are reasons for that we can get into in the next lesson. It's important to talk about, what does the y-intercept mean? What does the slope mean practically? The y-intercept, my $17,766.98. That's my y-intercept again. What that means is if we have a car that is brand new, age 0, remember that the y-intercept is the place where x is 0. So a car that is 0 years old, meaning it's brand new, would cost approximately $17,766.98. It might not be exactly that. It probably wouldn't be. That would be an approximation for it based on our data. The slope, so I'll write here, you can make some notes to yourself, new car price. The slope, my minus $862.05. This says that for each year older, the price decreases, goes down $862.05. And we need to use these really important words, on average, meaning some cars' values will drop a little more than others based on other factors, just then its age. And so this isn't not an exact thing. We are making predictions. We are estimating based on our data set. So we need to use correct language here, that for each year older, based on our data set, the price will drop $862.05 on average. So if we go to our calculator and we actually hit zoom 9, because we stored that regression equation in our y equals, and if you go to y equals, you'll see the equation. So that's another place where you can find your linear model, your linear equation, and it is a little more exact than ours because we rounded. It's graphed our line that best fits. We often call this a line of best fit. We call it a linear model. We call it a regression line, a trend line. There's all these different vocabulary words for this. But this line best fits our data. It does the best job of showing the relationship here between the age of our cars and their prices on CarMax. You can see it doesn't really go through any of the points. It hits a couple of them maybe, or is just really close. Some are above and some are below. And we will talk about what that means. But this line and this equation that we've written is going to allow us to make some predictions based on our data about what a Toyota Corolla would cost in this region of the country. It's important to be specific about that. There are different things about living in California than, say, living in the Northeast of the United States. That is snow and salt on the roads, which affect the price of cars. So we always want to be careful. We're being specific that we're going to use this to predict prices in this region of California or this region of the country. So we can use our equation to make a prediction about a 3-year-old car. We don't have a 3-year-old car in our data set, but we can predict what it might cost. So I am going to use my equation here, and I am going to quite literally, we're just going to plug. This is like substitution in algebra, and I have too many sevens. We are going to plug in 3 years into our regression equation. So I have my slope or my intercept minus my slope because it's negative times 3 years. That gives us a prediction for a 3-year-old vehicle. So our prediction would be 15,180 and 3 cents. I'm sorry, 83 cents. And we could do that same thing for a 20-year-old vehicle. And I'll show you a little shortcut. If I arrow up here to the equation I plugged in, I can hit enter and it kind of copies and pastes. And then I can go change my 3 to a 20, save myself a little time. We could predict a 20-year-old Corolla to be $525.98. So we can do we can use this to predict for different ages of cars. But what we need to do is we need to be careful. We should be careful about using our data to predict about a 20-year-old vehicle because the oldest car in our data set is 10 years old. 20 years old is twice that age. And so the trend actually might change as we get a vehicle that's that old, 20 years old. So it would be okay to predict for a 3-year-old Corolla because it's within our data set, but a 20-year-old prediction, this is probably not a safe prediction because it is so far outside of our data set that the trend or the pattern might actually change as they get this old. Another thing we can do is we can find residuals. Residuals are basically an error between what we actually observed in collecting our data and what we may have predicted based on our linear model, based on our line of best fit or our regression line. We have these things called residuals. And so if we want to find the residual for a 6-year-old Toyota, we first can locate on here where our 6-year-old Toyota would be. It's this data point right here. You can see it's below our prediction line. It's below our model. And so that means this is going to have a negative residual. That means we observed this car being sold for less than we would predict it for. If we were to look at our 10-year-old Corolla over here, it's above the line. That's going to have a positive residual. That means it actually sold online for more, or it was posted to be sold for more than we would predict it. It's just above the line. That doesn't mean one's good or one's bad. What it means is negative, our observed value is below the line. Positive, our observed value is above the line. And so if we could calculate the predictions for a 6-year-old and a 10-year-old Corolla, we can actually go back here and we can change this to 6 and change that to, whoops, 10. Those are our predictions for what a 6-year-old Corolla would cost based on our model and a 10-year-old Corolla. And if we subtract those from what we actually observed, so for our 6-year-old Corolla, we actually observed that it was listed for $11,998. We subtract from that what we might predict with our model, we get a residual value of $596.68 negative, which means it's just it means that it's below the line. It doesn't mean like we've lost money. Actually, what this means is this is actually a good thing for the person purchasing the vehicle because they're getting it for a price that's listed below what we would predict based on our data set. So a negative residual in this scenario is actually a good thing for somebody buying the vehicle because they're paying less than what we would expect. For our 10-year-old vehicle, we observed it being listed for $9,998, and the prediction we calculated was $9,146.48. Sorry, that got a little sloppy. And so we get a positive residual because it's above the line. We can see it by looking at our picture of $851.52. So that means that the person selling this vehicle has listed it for more than what we would predict based on our data set. And so actually in this case, it's good for the seller if they can sell it at this price because they're getting more money than we might predict. So one thing I want to show you too is we don't use computer programs in here, but you might run into a computer output where we have to pick off our slope and intercept. And so actually we are in this region of the computer output, and you're going to get a lot of information. R squared is something we get on our calculator, which we'll talk about again. We get a bunch of different things. We want to look right here. Our intercept underneath coefficient, that's our y-intercept. So 6.83 in this problem that we took this from. And then the variable that has a name, the number next to that is going to be our slope. So another way to display output from regression based on a computer model, this one gives us a lot more information than we need at this point, but we can pull out the slope and intercept if we know where to find them. Again, we look at the coefficient column. The number next to the word intercept is our slope, or I mean our intercept. And then the number next to one of our variables, so in this case, protein, we're comparing protein to total fat, that gives us our slope. So of course, before you go ahead and try this one on your own, I hope that you will ask any questions that you might have in making these calculations, making interpretations before you try one on your own. When you're ready, please do try these and we'll talk about them together. Take your time and good luck.